You walk into a supermarket, pick up an apple, and eat it. The question of whether apples count as food was settled long before you arrived. Other people grew it, inspected it, transported it, and placed it beneath a cheerful little sign announcing the price. An ancient human, entering unfamiliar land, had none of that. A plant might contain enough calories to keep the group moving. It might cause vomiting. It might do absolutely nothing until several hours later, when locating the responsible plant became slightly difficult because everything in the forest looked guilty. Nature does not label its products. So how did ancient humans know what was safe to eat? Most of the time, they knew because somebody had taught them. That answer sounds almost too ordinary. We like imagining prehistoric discovery as one brave person biting an unknown berry while everyone waits nearby to see whether lunch has been invented. That probably happened occasionally. It was also a terrible long-term strategy. No individual could personally test every leaf, root, nut, mushroom, animal organ, and shellfish in a landscape. Some toxins act quickly, others take hours. A few become dangerous only when eaten repeatedly. Even surviving the experiment would not necessarily reveal which part of the meal caused the problem. Ancient food knowledge had to become communal. Each generation inherited a menu shaped by thousands of earlier meals, including the meals that had gone badly. The first filter was already inside the mouth. Humans are strongly attracted to sweetness because sugar usually means accessible energy. We are also sensitive to bitterness, and many defensive chemicals produced by plants taste bitter. Bitter taste receptors probably helped our ancestors reject potentially harmful substances before swallowing much of them. The system is useful, though hardly perfect. Many harmless foods are bitter, and some dangerous substances give little warning through taste. Humans eventually learned to enjoy coffee, dark chocolate, and bitter vegetables, proving that our species can receive a biological warning and gradually turn it into a beverage industry. Smell offered another layer of protection. Rotting food can release compounds that trigger immediate disgust. Strange textures, visible mold, and meat from an obviously sick animal could also raise suspicion. But senses only provided clues. A plant might smell pleasant and still be dangerous. Meat could look normal while carrying parasites. A root might be safe after cooking and harmful when raw. Hunger also has a habit of making questionable ideas look increasingly reasonable. The body had one more defense: conditioned taste aversion. When someone eats an unfamiliar food and later becomes sick, the brain can build a powerful dislike for that flavor, even when several hours separate the meal from the illness. The connection can last for years. It is why one encounter with spoiled seafood can cause a person to feel ill at the smell of it long after the original event. That reaction would have helped individuals avoid repeating mistakes. The group could preserve the lesson through warning, imitation, or story. One person became sick after eating those berries. Nobody needed a biochemical explanation. Leave those alone was enough. Watching animals may also have provided hints. If birds repeatedly gathered around a fruiting tree, there was clearly something edible there for birds. That final part mattered. Different species process chemicals differently. A goat can eat plants that make humans sick. Birds can swallow fruits containing compounds their digestive systems tolerate. Pigs approach unfamiliar food with admirable enthusiasm, but they should not be granted full authority over human nutrition. Animals could point people toward possibilities. Human experience still had to finish the investigation, and this is where children become central to the story. In foraging societies studied by anthropologists, children begin learning food collection by accompanying adults. They watch where people search, which plants they select, how they remove the useful part, and what happens before anyone eats it. Much of that education happens without a formal lesson. A child sees the same action repeated until the method becomes obvious. Research among contemporary hunter-gatherers shows that children often join adults during subsistence work from an early age, while wider networks of relatives and companions expose them to different skills and sources of knowledge. These societies are not frozen copies of prehistory, but they show how complicated survival knowledge can move through a community without books or classrooms. Imagine learning a root from an elder. First, you learn where it grows. Then, you learn which leaves mark the correct plant. You watch how deep to dig and which part to keep. Later, you see it placed near the fire before anyone eats it. Nobody gives you a lecture on plant chemistry. The complete safety procedure is stored inside the demonstration. Dig here, take this part, prepare it this way. A child who copies the sequence receives the result of experiments conducted over generations. This is the real advantage humans had. We could inherit discoveries without repeating the danger that produced them. Preparation widened the menu even further. Many wild plants are difficult to digest, unpleasant, or mildly toxic in their original form. Heat can soften plant tissue, make starch easier to access, kill many pathogens, and reduce certain harmful compounds. Grinding breaks hard seeds and roots into material the digestive system can handle more efficiently. Soaking can remove water-soluble chemicals. Humans were slowly learning that an object found in nature did not have to be eaten in the condition nature supplied it. Consider the acorn. Acorns are rich in energy, but many varieties contain enough tannins to make them bitter and astringent. Traditional processing can involve shelling them, grinding them, washing the crushed material repeatedly, and cooking what remains. Leaching removes much of the tannin. A hard, unpleasant nut becomes flour or porridge. Nobody could guess that full sequence by looking at an oak tree. It had to be discovered, remembered, and taught. At some point, people learned that the bitterness did not mean the acorn was useless. It meant the acorn required work. This pattern appears deep in the archaeological record. A recent study of starch residues on stone tools from Gesher Benot Yaakov in Israel suggests that hominins were processing a broad range of starchy plants around 780,000 years ago. Much later, roughly 30,000-year-old grinding tools from sites in Italy, Russia, and the Czech Republic preserved starch grains from wild plants, showing that Upper Paleolithic people were deliberately turning plant material into something closer to flour. This was serious technology. The finished object may have looked like a stone with another stone beside it, which is admittedly less dramatic than a spear. But a spear helps when an animal is available. Plant processing knowledge can keep a group alive when hunting fails. It also allows people to use foods that other animals cannot access efficiently. A patch of tough roots becomes a source of calories because humans bring digging tools, fire, grinding stones, and accumulated knowledge to the meal. The landscape contains more food once you know how to change it. That knowledge was highly local. A group living near a coast needed to understand tides, shellfish, and seasonal fish movements. People in a woodland needed detailed knowledge of nuts, tubers, and game. Move either group into a desert, and much of their expertise immediately becomes less useful. The human body travels well. The human menu does not travel automatically. Entering a new environment would have been dangerous because familiar signals could become misleading. A plant might resemble an edible species from home. A fruit could ripen at a different time. An animal organ safely eaten in one species might contain dangerous levels of a compound in another. This made contact between groups valuable. People could exchange food, but information may have been even more important. A traveler shown where to find water, when a plant ripens, or how to prepare a local root receives years of experience in a single conversation. Research on hunter-gatherer social networks suggests that connections between communities help knowledge and innovations travel beyond close relatives and individual camps. Older people were especially valuable during unusual conditions. A younger forager might know the foods available during normal years. Someone who had survived previous droughts or harsh winters might remember resources used only when the usual ones disappeared. Studies of learning across the lifespan in foraging societies describe older adults as repositories of ecological knowledge, including the locations and seasonal patterns of important foods. Their physical productivity might decline, while the value of their memory remained high. An elder who remembered one obscure root from a famine 30 years earlier could become the most useful person in the group. Essentially, an emergency database with knees. Rules around food could also survive after the original incident was forgotten. A group might refuse to eat a particular animal during one season, or forbid children from touching a certain plant. The explanation could be practical, spiritual, or a mixture of both. Culture does not need to identify a toxin by name to preserve behavior that reduces exposure to it. Sometimes the explanation changes while the rule remains. That can protect people. It can also preserve mistakes. Human culture is extremely good at transmitting useful knowledge and completely baseless opinions, using the same confident voice. Ancient humans still suffered food poisoning. They ate toxic plants. They consumed spoiled meat. They misidentified species and took risks during famine. Archaeology cannot show us every failed meal, and the people involved rarely left a review. But the growing body of food knowledge changed the odds. One person could learn from another person's experience. A child could inherit the correct preparation technique before understanding why it worked. A group could carry familiar familiar foods into new territory and borrow unfamiliar knowledge from the people already living there. Over time, dangerous experiments became ordinary recipes. That is the deeper story behind human food. We usually describe ancient survival through weapons, fire, and physical endurance. Food knowledge required another kind of ability, paying attention to consequences and preserving the connection between an action and its result. Eat this plant only when ripe. Cook this root longer. Wash this meal until the bitterness fades. Avoid that animal when it looks sick. These instructions may sound simple. Together, they turned forests, coastlines, grasslands, and deserts into habitable environments. Human beings became successful omnivores, partly because culture could do what evolution alone could not. Our genes did not need to encode the identity of every edible plant on Earth. We learned locally, shared socially, and passed the answer forward. That is why the safest person in an ancient landscape was probably not the one willing to taste everything. It was the one who listened. So how did ancient humans know what was safe to eat? Their senses narrowed the possibilities. Experience removed some mistakes. Cooking and processing unlocked foods that once resisted them. But the largest protection came from other people. Every meal carried knowledge gathered before the eater was born. Each preparation method preserved an old discovery. Each warning kept a past disaster from needing a sequel. Today, we call that knowledge cuisine. Originally, it was survival memory. A recipe is an answer to a dangerous question that became familiar enough to serve for dinner. Thanks for watching. If you enjoyed this, subscribe for more. See you in the next one.